Hey everyone, welcome to Birch Talks, where we break down important topics in the science, law, and policy of climate change, decarbonization, and renewables. We're doing our best to help make the future of our world just a little bit more accessible. I'm your host, Matt Chalmers, science nerd, environmental attorney, and founder of Birch Citadel. Let's get into it. Today, we're going to be talking about heavy precipitation and pluvial floods. So heavy precipitation events are intensifying globally, reshaping landscapes, and challenging our understanding of climate resilience. For all of us, this trend is more than a statistic. It's a call to action. In this deep dive, we'll examine the latest insights from the IPCC's AR6 report, exploring observed trends, human influence, and future projections. Let's get into it and unravel the complex dynamics driving these changes and discuss what they mean for our planet's future. Let's go ahead and start off talking about observed trends in heavy precipitation. So the data shows that the frequency and intensity of heavy precipitation events have increased over most land regions within fairly reliable observational records. In other words, this isn't a local phenomenon. This isn't a localized anomaly. This is a global pattern. On a continental scale, the increase is evident in North America, in Europe, and in Asia. These continents have experienced significant intensification in extreme rainfall with medium to high confidence in the data. Zooming in a little bit further, regional assessments indicate that nearly half of the AR6 regions, including areas in Africa, South Asia, Europe, and the Americas, all show statistically significant increases in heavy precipitation events. These regions include West and East Africa, Southern Asia, Eastern Europe, and Central North America, among others. These findings underscore a critical point. The intensification of heavy precipitation is not isolated to one part of the world. It's a widespread phenomenon with far-reaching implications. Let's talk about what we know about the human influence on heavy precipitation. So, in other words, what's driving this trend? The scientific evidence that we have before us points to human activity. Specifically, greenhouse gas emissions are the primary driver of the observed intensification of heavy precipitation. This conclusion is supported by multiple lines of evidence, including climate models and attribution studies. In essence, our models indicate that climate variability alone cannot account for the observed increases. The signal of human-induced climate change is clear, according to the IPCC's AR6 analysis, and especially in North America, Europe, and Asia. But why does increased greenhouse gas concentration lead to more extreme rainfall? So, in a nutshell, as the atmosphere warms, it has the ability to hold more moisture. This is a fundamental thermodynamic relationship. In other words, it's basic chemistry and physics. This means more water vapor is available in order to fuel those intense precipitation events. There's simply more of it up in the sky. Here's the thing. Each degree of warming increases the atmosphere's moisture holding capacity by about 7%. That doesn't seem like a lot, but think about how that aggregates up every degree. More moisture in the atmosphere means more potential for heavy rainfall, especially when conditions trigger convective storms. In some regions, this human influence is already unmistakable. High confidence data from recent decades show clear signs of anthropogenic impact in areas like Central and Eastern Europe, the Eastern United States, and parts of Asia. So let's talk about future projections. Looking ahead, the future of heavy precipitation is intrinsically tied to global warming levels. Projections show that as temperatures rise, heavy precipitation events will not only become more frequent, but also more intense. So just to walk through a basic scenario, at a 4 degrees centigrade increase above pre-industrial levels, rare heavy precipitation events, those that currently occur every 10 or 50 years, would become significantly more common. What was once called a 50-year event might now actually occur every decade or every 15 years. The other thing is, it's important to understand this increase is not linear. Rarer extreme events will see a disproportionate rise. So for example, the frequency of 10-year events is likely to double, while 50-year events might triple. The physical mechanism here is straightforward. Warmer air holds more moisture, leading to more intense downpours. But regional factors, such as atmospheric circulation changes and storm dynamics, also add some complexity. This regional variability means some areas will experience more extreme impacts than others. Understanding these regional differences is crucial for accurate climate modeling and effective adaptation strategies. So with that, let's go ahead and talk about impacts on flooding and infrastructure. In other words, what does this mean for us? One of the most immediate consequences of increased heavy precipitation is the rise of pluvial flooding. This occurs when rain intensity overwhelms the natural and artificial drainage systems, leading to surface water and flash floods. In other words, floods that are a result not of something coming in from waves or offshore, it's from heavy precipitation. Recent events have shown how devastating these kinds of floods can be. Urban areas are particularly vulnerable due to their impervious surfaces, asphalt, concrete, etc., and aging infrastructure, meaning you don't necessarily always have the full ability to move that excess surface water off and away from cities that they were designed to originally be able to withstand. So, for scientists and policymakers, this means there is a pressing need to rethink urban planning. Enhanced drainage systems, green infrastructure, and better flood forecasting are no longer optional. They're essential. So let's talk about moving from thinking about this to what can we do? Understanding the science of heavy precipitation is just the first step. The real challenge lies in applying this knowledge to mitigate impacts and build resilience. So, when it comes to anyone who cares about the science and the policy, our role is to try to do our best to provide the data and insights that we can into the policymaking process to help inform smart policies and adaptation strategies. This means a continuous improvement in climate models is important, deeper regional studies is important, and most of all, maintaining a clear line of communication between scientists and the technical folks who are generating this knowledge and policymakers and their suites of stakeholders that are going to be able to actually implement some of these changes. The intensification of heavy precipitation isn't a distant threat. This is something that's happening right now. But with science, innovation, and global cooperation, and with cooperation between those who are putting this data together and those who are using this data out in the field, and all of the stakeholders that are involved in that process, if we're able to all collaborate, we can navigate this challenge and help build a more resilient future. Thanks so much for tuning in and listening. For more in-depth resources and research updates, feel free to check out the links below. Together, let's advance climate science and do our part to make the world a little bit brighter. Thanks so much.